We've been at this quest for quite a while now. We still don't have a clear definition for artificial intelligence, but maybe the problem, maybe why it's so hard to pin down, is that it's not just one thing. Maybe it lives somewhere along a spectrum. Let's give that a test today. Our plan, we're going to start with reviewing what our other definitions are, see where they fell short, and hope that gives us some insight on how the spectrum might help out. We're going to give the spectrum definition, and in fact, it's not just one. There are 3 different ones on offer. We'll look at the weak versus strong AI, narrow versus general AI, and then weak AI versus artificial general intelligence versus superhuman general intelligence. See if one of those does the trick. With those definitions on the table, I'll look at their pros and cons. Spoiler, there are a couple of pros and there are a lot of cons. We've already considered 3 definitions. First, that artificial intelligence are machines that pass the Turing test. Then we considered, well, maybe AI are computers or things that do things that were a human to do them. We'd call those humans' actions intelligent. And that came from McCarthy in the 1956 DARPA conference. We considered that AI are artificial minds in the true and literal sense. That's Hagelin's view. But I found each of these 3 definitions lacking, right? The first one, it's not good enough to do a Turing test because imitation isn't the same as actually being artificial intelligence. And that also didn't seem like it captured some of our core cases. On the second one, it felt good as a definition for the science of artificial intelligence, but it didn't describe why objects themselves were artificially intelligent. And then to the extent it did, it was a circular definition. The AI were things that did intelligent things. Well, the intelligence shows up on both sides of that definition bar, and I didn't see a clear resolution there. And lastly, when we looked at Hagelin's accounts, that was focused just on good old-fashioned artificial intelligence and said that there's really no artificial intelligence in existence yet. Now, maybe that's true, but that still cuts against our ostensive definition that says there's a bunch of things out there that we want to call AI, from our chess engines to Netflix recommendations to smart watches and software on my computer. And if those things don't count as AI, then Hagelin's already pushing back with need for some sort of error theory. So what we see here is one definition was too inclusive, another definition was too exclusive, and the other one was entirely exclusive. We want something that allows a lot of things in, but with sort of principal boundaries. And for that, let's take a look at the spectrum definitions. A spectrum is just a classification of something in terms of its position relative to extremes. And usually we're thinking 2 poles. I suppose it could be more. In this case, we're going to be looking mostly at 2 different polar extremes and identifying artificial intelligence as something that lies in between. So when I say, what's our 4th definition? Well, it's going to be one of the following spectra that we'll consider, and the definition will say that artificial intelligence are things that fall on one of those spectrums. Spectra, I don't know what the right plural is. I think both are acceptable, but spectra sounds more pretentious, so I'll probably go with spectrums. So now let's consider each of those 3 spectrums in turn. First, weak versus strong. There's already an issue here because if you look up what is meant by weak versus strong AI, the first place you're going to go, hopefully, is John Searle's famous paper about the Chinese room. That is a wonderful and interesting and important topic for us to cover, although we're not going to get into the details of the Chinese room in this episode, so stay tuned for that coming up. But Searle thinks that there's weak AI, which is just the claim that artificial intelligence are tools, and then there's strong AI, which is that artificial intelligence are minds in and of themselves, which, if you're watching the series, should ring some bells in thinking about Hagelin's view on what AI actually is. Let's set Searle aside for a minute and talk about the other use of weak versus strong AI that you'll find if you go out there looking, and that's just about in terms of power. So we go from the very weakest, I don't know how many of you play chess on chess.com, but you've got Martin, the super easy bot, the 250 rated or whatever, all the way to your Morphe bot over here on the right, probably like 2,500 rated, something like that. I'm sure there are some stronger bots now. I don't play the bots as often. But what's more powerful, that's what our weak versus strong AI continuum is for. But what exactly do we mean by power? And I'll just stick with some chess analogies here. But a lot of different measures on which you can say something is more or less powerful. Maybe the AI has more processing speed, or greater memory, or more information that it can leverage. Maybe it's got more complex inferences, or lastly, a bigger breadth of expertise. And that we'll see more on in a second, but just to cover what those former examples might be. So if we're thinking about a chess engine, what could make it more powerful? One thing is it could have a bigger opening database that it's drawing from, a set of mid-game tactics, and those things would be just more access to information, right? It might also be better processing speed, and that's just going to straightforwardly be how fast does it give you the answer. Or it could be something about memory and capacity that tells us how many moves in advance does the chess engine look to analyze a position. All sorts of things we can imagine here. But this breadth of expertise really warrants some more thinking, and that actually takes us to our second spectrum: narrow versus general artificial intelligence. Narrow versus general artificial intelligence is all about how wide the domain is of expertise for the AI. So on the far left here, we have examples that are very laser focused to a specific use case. Maybe our reCAPTCHA machine is just determining whether the user of some web service is a human or not. Or even if we want to go a little farther, Stockfish, while it maybe covers a bunch of different chess openings, it's just thinking about chess. Contrast that with a game player algorithm that you might try and create, where maybe there's an AI agent that could play chess or Go or Monopoly, something like that. Right? As we widen the amount of things that the AI can cover, we go further and further over here towards general instead of being over here in very narrow, but all of them count as artificial intelligence on this view. And then the last spectrum we're going to consider has three parts: weak versus AGI versus SGI, which is weak artificial intelligence versus general artificial intelligence versus superhuman artificial intelligence. I've seen the S stand for a couple of different things. Sometimes it's SGI, sometimes it's like ASI. We'll get to this later, but there's really not a consensus on what each of these spectrums should be. And here we see that weak AI and AGI, that's actually not different from the previous slide, but now we're adding one more component. So do we have something that's domain specific versus something that is as versatile as a human versus something that is even more? It's superhuman in intelligence. Not exactly clear what that's going to look like, but something like the super advanced robots from the Matrix might be an example here. With these three spectrums on the table, let's think about what's good about them as our definition for AI. And the first thing I think is pretty obvious here, it's inclusive. All of the things that we would want in sort of our ostensive definitions are going to fall on this list. AlphaGo and Stockfish, they're AI. They're domain-specific AI, so maybe they're on the weaker side, but they're artificial intelligence nonetheless. And even as we get stronger chess engines, as I mentioned, those are a little bit stronger AI. We can look at things like autonomous vehicles or Netflix recommendations, or if we want to consider the Terminator or Rosie from the Jetsons, all of these things would fall somewhere on one of these different spectrums, and that counts in favor of the definition. We want something that can situate all of them, so that's pretty cool. Another virtue of this definition is that it's thought-provoking. Maybe this isn't something that tells us that the definition is right or not, but it's definitely a benefit I felt when making this video, as I try and lay out the different arguments for why, where something would fall on a spectrum. It has me asking questions that I think are central to artificial intelligence. Like, what counts as power? Is this about computing power and processing speed? Or is power about how true the conclusions are or how useful they are to humans? It also gets us asking about, really, okay, fine, we have AI and AGI and SGI, but where are those cutoffs? How do I know when something is artificial general intelligence? What does it mean to be superhuman general intelligence? But those are all the good things I have to say about this as a definition for artificial intelligence. There are quite a few cons. Let's go. First, it's a circular definition. Essentially, it says that artificial intelligence are things that are on this artificial intelligence spectrum. And the second and most critical, probably, con against this definition is it's just not a definition at all. where to the extent it is, it's an ostensive definition. When I was making the graphics for the previous slides, I wanted to know, okay, what pictures should I throw up on there? And I considered the Roomba and the CAPTCHA, and so I put them on sort of near the weak end of the weak versus strong AI picture. And I was like, well, do I want to count the CAPTCHA as artificial intelligence? And the Spectrum account didn't help me decide at all whether it should go on there or not. I threw it on there, what the heck? But really, if I have a definition, I want necessary and sufficient conditions. I want something that tells me for sure this thing goes onto this list. And the Spectrum definitions just don't give that for us. Now, we could avoid that problem by just listing the things that have to show up on the spectrums, but then it's not a definition in the sense that it's a spectrum definition. It's just an ostensive definition that is a list of all the things that count as AI. And then we have this added information about how we can sort these artificial intelligences based on their strength or their generality or their superhuman level of intelligence. This did make me think a little bit about different types of definitions that we could use here. So we could talk about AI as a cluster concept. I don't think this is actually going to work, but I figured it's worth at least a footnote in this video. Cluster concepts. If we take cats, for example, I might want to come up with a definition of cats. This is something that you do all the time in your intro to philosophy classes. And I say, oh, cats are four-legged, furry creatures with tails. And you say, but what if one of them doesn't have a tail? You're like, well, yeah, that would still be a cat, but it would still be a furry, four-legged creature, right? We come up with lists of criteria, and we say something that has the weighted majority of these things counts as an entity of that sort. Now, that's actually not going to work for cat eventually anyway, so just take that for illustrative purposes. But the idea might be that artificial intelligence checks some combination of boxes, that none of which are necessary or sufficient, but a weighted majority of such are going to be sufficient to call it artificial intelligence. Maybe they have to do some computing, and they have to be able to imitate people in at least some capacity, right? We could try and piece those things together. I don't think that's going to work, but worth flagging. If you want to run with that, go for it. Third con to this definition, it doesn't give us any guidance really how we order things along the spectrum. So take three objects that conceivably are artificial intelligence that function in your house: a thermostat, some sort of biomarker door lock, and motion sensor lights. And let's just consider the weak versus strong artificial intelligence, or at least the narrow versus broad. On either of those accounts, which of these is the broadest or the strongest? And I could stare at this list for a long time, and I don't think I'd be able to tell you. Does that mean that they're all equally strong or broad because they each serve one particular purpose? I mean, maybe. But the fact that I don't even get any guidance whatsoever from our spectrum definitions and how to do the spectrum ranking makes me think this isn't the most helpful definition to have. Doing research for this topic was pretty difficult. Now, it's not hard to find references to AGI or strong AI or weak AI. Go scroll through LinkedIn and it'll be all over the place. People proclaiming, mostly people who are selling artificial intelligence, and say AGI is here and their company has it. But there's no consensus on what these spectrums actually are. That's why I have three of them, because those are the most prevalent ones. But I've seen others, and people talk about strong versus weak in different ways. Refer back to the part of the video where I talked about weak versus strong, and that definition originates in John Searle's work, but John Searle's not talking about strong versus weak in terms of the power of the AI. He's talking about whether it's just a tool versus having a mind. And this lack of consensus is a problem. One of the reasons to adopt maybe the Turing test or the 56 DARPA conference definition is that at least they were widely adopted within some community. People know what the Turing test is. 56 DARPA conference shaped the way that computer scientists think about artificial intelligence. So going with those definitions means at least we've got some inertia that we're building upon. But these spectrums, they're being used by different people in different ways. Like, we're not really jumping on a train that's already moving. We'd have to actually be herding the cats together to get a spectrum that made sense and then running with that one. And I don't think that's a very practical approach to go, irrespective of whether it's a principled definition, and I don't think it's principled either. Lastly, AGI and SGI are mysterious. Not only do different people use different letters, whether it's ASI or SGI or whatever, I don't exactly know what AGI and SGI are here. At present, I think everybody says we don't have SGI. I don't think we have AGI either, but you will have some contention about that. Again, as I said before, especially by people who are selling you something they say is already AGI. Maybe ChatGPT is AGI. Maybe that's what Sam Altman wants to say until he realizes that that sets crazy expectations for what his company needs to be able to do, and then you have to back off those a little bit, right? You want the expectations when you're getting the funding, but then not when you're having to do the delivering. That's common for all of us. But I really don't know what AGI versus SGI are. And if this definition doesn't help me understand what those are, then what good is it doing me? Okay, let's summarize where we're at for spectrum definitions. Definition number 4 says that AI are things that show up on an AI spectrum, which is something like weak, narrow, or domain versus strong, broad, or general versus superhuman intelligence. But this is more of a list than a set of necessary and sufficient conditions, and it's still unclear what makes something truly general or superhuman. So, next time, I think we've hit it. I think we've hit the point. I'm going to give you my answer as to what artificial intelligence is. If you've stuck with this video this long and this series this long, you must have just left the playlist on autoplay or something, or you're really excited about my answer, and I'm excited to give it to you. So stay tuned. In a week or so, I think that video will come out, and I'm really excited to see the reaction. Thanks so much to everyone for watching this video, for commenting, for participating in my channel. We'll see you guys next time.